Now, configuration. How should I configure my Scylla boxes to take the most out of it? Usually this is something that shouldn't be of a lot of concern. You just run the Scylla setup. The Scylla setup will configure everything for you. We also, as I said, invest a lot into making sure that Scylla is essentially as close as zero conf as possible. But there are things that we still see people getting wrong every now and then. Scylla setup is an interactive program, so it will sometimes ask you questions and you're going to say, well, yes or no. So I want to expand a little bit on which questions are really important that you say yes to, or at least understand what is the impact of saying no. And also it goes deeper than that. When I'm talking about configuration, I'm also talking about like how to configure your racks, how to configure your topology, and etc. So how to essentially get the Scylla cluster ready to go. So let's talk about racks first. So I have my nodes, and they live in the same data center, but I want to take a look at how do I configure them? How do I place them in different racks? General advice, have as many racks as you have replicas. So if you're running on a replication factor of 3, which is the most common setup that we see, run it in 3 racks. Simple as that. So if you're on the cloud, you're talking here about availability zones. Can you deviate with that? Sure, but like this is, I'm going to show you like what are some of the side effects of doing that. Why do we give you this advice? Because Scylla tries to place a full copy of the data into each rack. So if you configure your cluster to be multi-rack and you have 3 replicas in 3 racks, I will guarantee to you that you have a full copy in each rack. So if you lose the rack, you lost the copy, but just the copy, right? This is what happens, right? So if you're doing quorum reads and writes, you're not going to even notice. If you lost the full rack exploded, like it was a nuclear war or something like that, and you lost an entire rack, you don't notice. Well, you might notice the nuclear fallout in that case, but you're not going to notice that their database is having any issues. Your queries are maintained. You haven't really lost any data. There is no situation here in which there was data that was there and is no longer. It's just no problem. So this is how it should be. However, if you have 3 replicas in 2 racks, can I do it? Sure, yeah, you can do it. But what happens is I'm going to put my first replica in one of the racks. I'm going to put my second replica in the other rack. And then the third replica, since there isn't a third rack, I just have to put in one of them. And then what happens? If I am lucky, and I lose the rack on top, I lost the replica, and I'm cool with that. My quorums are maintained, nothing happens, I didn't lose any data. But if this morning I was walking down the street and I happened to see a black cat and it was Friday the 13th, or if I just exist, because let's face it and let's be honest, this is more likely a scenario. Usually being lucky is the exception, is not the norm. What's going to happen is that you're going to lose the rack in which you had 2 copies. And I can actually guarantee you that this is what's going to happen, because situation in practice is not like there is this one rack that is going to be hosting 2 copies. Part of your keys are going to be in this rack, the other part of so you're going to lose something, right? This is guaranteed to happen. And you just might have lost your job. So depending exactly on your consistency guarantees. So I mean, this isn't something, this is one of the things that we've heard recently from a customer, like if I lose this cluster, I lost my job, and they had everything in a single rack. And I said, I hope you don't like your job too much then, because that just might happen. And obviously we work with them, like how to make this now into a 3-rack situation. I happen to like the guy very much. I wouldn't like to see him fired. And it can happen. Like if this is this mission critical, there are some clusters who are not mission critical. You can lose the data, it's fine. And for cost reasons, you might want to put it in a single rack, then there is really not much reason to do it in 2 racks in that case. Even single rack is a valid use case for those situations in which you're fine in case Google or AWS or Microsoft just lose an entire rack. Otherwise, just keep those things matching. To actually make that work, you have to choose network topology. Moving from simple strategy to network topology is a major pain. So my recommendation, always, always, always use network topology, even if you're not on a single rack, because it will make your life easier later to make those changes, right? So use network topology all the time. This is what tells, if you're not using network topology, you can have as many racks as you want, but that tells Scylla, I don't care about placement. Network topology is how you tell Scylla, I care about placement. And then you're going to place your copies in the right racks. And then obviously when expanding the cluster, if you are on a single rack, you can put just one node. But if you are on 3 racks, you want to put 3 more nodes because you want to keep those racks balanced. Right? Otherwise, again, remember, we're going to put a full copy in each rack. So if you have imbalance there, you're going to end up with imbalance in the sizing of your nodes. And do run, as I said, do run the setup tool. But if I had to pick one thing, I didn't have to, but I could have picked a lot of things, but just to highlight it and enhance it, if I had to pick one thing that people keep doing it wrong, and I could tell an audience, just pay attention to that, which happily I can because I'm here on stage, which is configure your network. What does that do? I'll explain what exactly it does, and it will become clear why this is important. When Scylla Setup asks you, do you want to configure your network interface? What it does is it pins the interrupts in which the CPUs in which the interrupts are going to be delivered. We do pinning of this interrupt according to your hardware. So there are 2 major ways in which we do it. If you don't do this, what ends up happening is that the operating system will unfairly deliver interrupts to a couple of CPUs. It doesn't have to be 1, but maybe there are 3, 4, 5 CPUs out of your 30 that will get most of the interrupts. Those CPUs are running Scylla as well. Again, because you said don't tune it. You said don't do anything with it. So those CPUs that are hosting a part of your data, they're going to start to get slower to serve your queries because they are busy serving the network interrupts for all of your machine. When you say yes to this question, when you say, yes, I do want to tune my network interface, what we are going to do is that we're going to look at your hardware and make a decision to use one of those 2 modes. One of them, I will isolate 1 or 2 CPUs. So it also depends on your hardware, but I might isolate 1, I might isolate 2 CPUs just to handle your interrupts. And if you do have enough hardware queues and a lot of other things happen as well, I might decide I will put all of this in the first case, of course, Scylla will not be running in that CPU, right? So the interrupts are all going there, but Scylla is not running there. In the other scenario, I will still run Scylla in all of the CPUs, but I will make sure that all of the CPUs are getting interrupts, and all of the CPUs are getting interrupts fairly. So yes, they all pay a price, but they all pay around the same price. We decide that based on the number of network queues that you have. Very, very, very common. People say no to this question because it doesn't sound like important. We actually have been trying to convey this importance in the message more and more. But if you don't do it, you end up in the scenario over here. One of your CPUs is going to pay for that. Yeah, another one that we actually, we want to put it in the setup tool soon. This is actually a problem we've just discovered, your clock source. But until we do, I mean, you might want to check that out too. What is your clock source? Your clock source has nothing to do with NTP or timekeeping of wall clocks. It just means what physical device do I use to produce information about what is the current time, to essentially do timestamps. Scylla is a very timestamp heavy application. So you can have a variety of choices of which device to use. The fastest one is just your processor TSC, which is essentially every time it gives you, like, it used to be a cycle counter, I'm not going there, but this is the fastest one available. If you're running on AWS, for instance, on the older i3 machines, you might be using the Zen, from the Zen hypervisor, the Zen clock source. Just for you to have any idea, if we measure how long does it take to get a timestamp from each of those clock sources, if you're taking it from the TSC, it takes around 25 nanoseconds. If you're taking it from the Zen clock source, it's going to take around 100 nanoseconds. So what that means is that every time you go there and you have to take a timestamp, which we do all the time, you're going to get 4 times slower. We're going to integrate that soon into the setup utility, but for the time being, you might want to check that out.